Right. So what have you done? Oh, you're recording. Good.
It started. 30 participants are on.
Really?
Yeah.
Can't hear them.
No.
Oh, Alan Vaughan's on. Hello, Alan. That's great. So, people are watching. Can they hear us?
They can hear us, but they can't talk to us.
No. Okay.
At this stage. But if anyone has any questions.
So questions can be typed in, is that right?
Yeah. We'll wait a few minutes and we'll start on time.
Yes.
Hello, Matthew Young.
Hello, Bill Garside. Hello, Andrew Stevenson.
Hello, Barbara Briggs.
See, we're only at sea.
Here we are. We've got a lot of people. 119 people. Hello, everyone. You must all be bored. Hi, Cheryl. Lots of new names on here, which is lovely. Hello, Diane Ogg. You could be a relative. Hi, Libby. How are you? Gail. I feel like Magic Mirror. I can see Gail and I can see Jeff.
I think you should be saying hello individually to everyone.
There's just too many people.
It's too selective, is this? And you've only got to G.
Good evening, everyone. Yeah. John from Paul Payne's group came to Siding Springs with you in April. Hi, Jonathan. Nice to see you again.
Well, that's great.
Hi, Kevin. Looking forward to talking to you too.
Lift the camera.
Lift your camera up if you can, man.
I think we're stuck with what you've got, but that's all right.
I won't be on for long. It's all right.
Important thing. Some young man behind you. Thanks, Terry. Yeah. That's probably true in 1958.
Peter Teague sent us a message.
That's nice. Peter.
Yeah.
That's great. You're going to have your work cut out, Marnie.
Yeah.
Keep up with all these messages. Very good.
Yeah. Okay. Well.
Oh man.
Oh, here comes the cat. Can we just?
Yeah. This is the real boss of the house.
This is the family manager.
Mm-hmm. Very noisy one too.
So, yeah.
Hi, Mandy.
Hopefully you'll be quiet now. He's got attention.
Have you paid for this? No.
We will.
Very nice to see you all there. All 157 of you. I'm totally enraptured by the attention that this idea of a webinar has caused. It's great to have this opportunity, and maybe it's one of the positives of the dreaded COVID-19. So just to give you a running commentary, Marnie's feeding the cat again, once again, because Mandu is not quiet unless he's eating, and he's not very quiet then either.
All right, so for those of you who have used Zoom, you have discovered the little chat button down the bottom where you can ask questions or send messages throughout the evening. If you've got a question whilst Fred's presenting tonight, flick that down and I'll get those questions to Fred. It's romper room, says Bill. And we'll get the questions at the end. So the format for the evening is that Fred will do his presentation. And as I said, if you've got questions along the way, that's fantastic. We'll try and take as many as we can. At the end, we will try and even open the microphone to a few people, because I know some of you are sitting in your living rooms by yourself, and it's probably quite nice to have a bit of company tonight. So, does anyone, 11 new messages, he's a good doobie, very good. Anything else, Fred?
Well, all I'm concerned about is the IT. We're very much hoping that everything works as planned. if it goes anything like the Skype conference I had this afternoon, you might as well go home now. Oh, wait a minute, you are at home.
But we are recording this, so if we have any issues, we can send you the link for it tomorrow.
Yeah, there you go. That's a great
Oh,
idea.
and actually on that, if you are experiencing difficulties, please let us know. It might just be your bandwidth in your house that's having the difficulty. But if we get a lot of people telling us, then obviously we don't want to keep you hanging on in difficult audio conditions, etc.
All right.
All right. Shall we get going, Fred?
Let's kick off then. So I have to go out of the romper room into whatever it is.
You have to go into that square.
Into the room where there's a picture on the wall. There'll be a prize for the person who identifies where that is. And then I'll connect and show my screen. Hello, Mandu.
Fred's makeup. Mandu did Fred's makeup. Thank you. Yes.
You can tell, can't you? Yes.
Go on, go away. And just to give you a little bit of background for those of you who haven't joined before, Fred and I have been doing a series of talks called Fred Watson Presents semi-regularly, between 4 and 6 times a year, where we get people along to a room in Sydney with some drinks and some nibbles, but obviously with coronavirus that hasn't been possible. So putting this online is just fantastic, and to see so many people from actually all around the world is great. So Fred, do you want the drum roll, or Mandy's trying to claw my leg, sorry. Without further ado, Fred Watson.
Thank you, Marnie. Thank you, everybody. It's Fred Watson and the Kodak Grayscale, which is by kind permission of David Malin, whose name is at the bottom, and who you will hear more about this evening as we go through this little talk, which is entitled The Universe for Everyone. And well, as you know, it's not rocket science, or I suppose it is then really, because we might touch on the space world a little bit, but this is really more about astronomy and stargazing. As Marnie's mentioned, the webinars have come about because the style of presentation has changed due to things beyond our control. But it's really been a really interesting exercise for me to turn what would be a normal talk. Actually, this is almost a new talk. You might recognize some bits of it if you've seen some of my talks before. But to turn a normal talk into something that will be suitable for sending people via the internet, which is not always as smooth and silky as you would like it to be, with things like, you know, animations and transitions. So a lot of that stuff's missing from this presentation. To me, it looks clunky. To you, I hope it will look adequate. So we might kick off. The universe for everything. And indeed, excuse me, it's not rocket science. All right. I'm Fred Watson, and that is my job. I work for the Department of Industry, Science, Energy and Resources, which consists of 3,000 grown-ups and 1 astronomer. But fortunately, I have friends in universities who are equally as astronomical and seem to like having me around too. So it's very nice to have those affiliations as well. I guess pretty well every talk I've ever done. This is a trilogy in 4 parts. If it was good enough for Douglas Adams, it's good enough for me. I've never really managed to get one down to 3. And if I did get it down to 3, well, I couldn't use this joke, so it would be pointless. So this trilogy in 4 parts consists of the following. First of all, I'm going to say a little bit about how I got to be sitting here in front of you this evening. My story, if you like. It's got a few interesting twists and turns. We might do that just to give people time to get online who are a little bit late, because that's the least important part of this evening's proceedings. But what I want to concentrate on is how anybody can engage with the sky, can get involved with astronomy. And you know, it ranges from standing underneath a clear sky on your own and wondering what it is you're looking at, to, you know, much more involvement with things like astronomy clubs and star parties, we're not allowed to have them anymore, but star parties, things of that sort. All of that is in this little chapter of my talk. But then I want to show you something that I think is absolutely inspiring. And this is what can be done today with the kind of equipment that amateur astronomers, amateur sky watchers have at their disposal. And it absolutely rivals what the professionals would have given their right and left arms for 20 or so years ago. I want to take you on a little slideshow through some of the best current amateur images, which are really quite astonishing. They're beautiful and often contain a lot of scientific information as well. And then finally, we might wrap up with a few words for anybody who'd like to take their interest in astronomy a bit deeper. I know that some of you are professional astronomers, you're already involved with astronomy in one way or another, but some of you might want to know what to do next. There's a lady here who's come into
your colour cut charts on. We can't see the pictures because you've got the colour chart.
That's really interesting. Well, that's something we haven't seen before. No, the talks, I'm actually giving the talk, so...
No, where you've got the colour code, the issue we had before.
Marnie's telling us an issue. Can you see my screen with a trilogy in 4 parts on it? Marnie's going to show me what to do. Okay, all right, that's very interesting. Oh, I see, I understand. All right, well, that's easy to fix. Thank you, Marnie. It's very good to have a producer for these things, especially when the person who's doing the talk has no idea what he's doing. But I think if I do that and that, in fact, I'll just get rid of that altogether. Let me just go back to the talk. It should come up. Now, Marnie, can you see it now?
Yes, it looks fine.
Hey, that's good. So we got rid of the color code. Sorry about that, everybody. These glitches are all part of the learning process when you're doing your first webinar. I'm absolutely thrilled that you can see anything at all, to be honest. All right, trilogy in 4 parts. What's an astronomer at large? Astronomy for everyone. And then those wonderful images. And then just to wind up, as I was saying, a little bit about how you can take your interest in astronomy further. And maybe this has some information that might be worthwhile for anybody who's at school or university who's watching this and wondering about their career, because there are careers in astronomy and associated sciences. So that might be something that you might be interested in. That's why I put it in the talk. So let's kick off with a little bit about the astronomer at large. And my story goes back to the north of England. And in fact, I grew up in an environment that today looks like this because it's a lot cleaner than it was when I lived there. I grew up on the edge of a city and the whole landscape seemed to be moorlands and mill chimneys. In fact, when I grew up, it looked like that. Everything was covered in soot. And they used to say that even the rainbows were black and white. It was a very black and white environment. And so we were enchanted by anything colourful that came into our lives. And the most colourful thing in my life, and some of you have heard me talk about this before, so forgive me if you have, the most colourful thing in my life, oh dear, was a comic, and it was called The Eagle. And The Eagle was a full colour, very high quality kids comic, which flourished from 1950. It was in its heyday when I was at school in the late 1950s and early 60s. And it was a very high quality production in every way, most especially by its front cover story, which was always a story involving, as you can see, I hope, Dan Dare, the pilot of the future. Now, Dan Dare was an interesting character. He was, it wasn't that long before Dan Dare appeared that there had been a world war with a lot of military heroes. And he was kind of that, but he was also clearly a pacifist and a great defender of the planet, because he had all kinds of things to face up to. But he was a colourful character and, of course, somebody that we all admired, even though he was fictional. Now, if you've got high enough resolution on your screen, you might see that underneath the story that's being told there, which is The Reign of the Robots, there is a name, which is Frank Hampson. And Frank Hampson was the artist who drew Dan Dare. He wrote the stories, invented the technology, and you can see this is this actually comes from, I think, 1958, which is actually in the dawn of the space age, and yet Frank Hampson was drawing things that really mimicked the kind of technology we're seeing today at some level. So not only was he a great artist and a great storyteller, but he also had a really strong technological background, and that spilled over in these stories. And all the people who took the Eagle had this really strong interest in space and technology. Something about Frank that I only noticed recently, he's long gone, of course, Frank Hampson, great, you know, a great artist and communicator, but now sadly no longer with us. But in one of his episodes, there is this set of frames, which you won't be able to read, but what it shows is the scientific boffin, as they were called, who accompanied these swashbuckling space heroes around the galaxy, was a young woman. Her name was Jocelyn Peabody, if I remember rightly. And I don't know whether you can see that frame up in the top right-hand corner, but into Jocelyn's voice, Frank Hampson put the scientific content of these comics. And there's Jocelyn explaining how spectroscopy works. This is, you know, this is astonishing stuff, way ahead of his time in the world of STEM. And a wonderful, I think, a wonderful tribute to a man who clearly had his horizons set much more broadly than simply drawing space heroes on a bit of paper, which tended to be the genre of the time. So the Eagle formed part of the education of most of us in that era. The other thing about the time in which I grew up is, of course, there had recently been a world war. Everybody thought there would be another one. And so the country, and that was the United Kingdom, needed scientists, and so science was very much in the ascendancy. And that's how we were all educated. Most of my peers at that time went off and went to university, did sensible things like engineering or medicine or architecture. I'm afraid I never grew up. I just stayed inspired by the likes of Dan Dare and Jocelyn Peabody, and studied astronomy to become an astronomer. It had its rather rugged path for a while, but that's something we didn't go on to. Just very quickly, I worked at the University of St Andrews for a while on the orbits of asteroids. I went then to the Royal Greenwich Observatory, which wasn't at Greenwich, it was in deepest Sussex, to work on the orbits of planets. After which I went to the Royal Observatory in Edinburgh to work on the orbits of stars in our galaxy. You can sense a common theme here. This is a depiction of the galaxy. It's a very nice little video animation that shows the home of the sun and its planets in the universe. We are one of about 400 billion stars in this flattened disk of gas and dust and stars, which we can never see from the outside, but we know pretty well what it looks like through the studies that astronomers have made over the decades. So I studied orbits in our galaxy, as well as occasionally in other galaxies. And then I came to Australia and eventually became the astronomer in charge at the facility on a mountaintop called Siding Spring in northwestern New South Wales. It is in the Warrumbungle range of mountains. As I've said many, many times, Warrumbungle is a Gamilaroi word. It means crooked mountains, and it absolutely describes them perfectly. So within that large building, which you see there decorated with a ribbon, which actually was Marnie's idea. That was for its 40th birthday back in 2014. That's the walkway, the catwalk around the dome, along which astronomers can walk to have a look at what the night sky is doing. This was in the days before you could look on a camera or look at a radar picture to see what the weather was doing. Excuse me, in the days, you needed to know by going and having a look outside. Inside that dome is the biggest visible light telescope in Australia. It's called the Anglo-Australian Telescope, built jointly in the 1960s and 70s by the British and Australian governments, with a mirror diameter of nearly 4 meters, 3.9 meters. Some of you might be able to spot a scientific celebrity in the background there. Young Brian Cox is admiring the Anglo-Australian Telescope. I was the astronomer in charge of the facility, which I share, the job of running the site was shared between the astronomer in charge and the operations manager, who looked after the engineering. I was responsible for the scientific output of the place. But I also got involved with some of the projects, of course. This is one of the results from not that telescope, but the smaller of the observatory's telescopes. And by the observatory there, I mean the Anglo-Australian Observatory, as it then was. A thing called the United Kingdom Schmidt telescope made maps of the universe, as did the bigger telescope. This is one of those maps. Every dot you can see on there is a galaxy like the one I just showed you in that animation. And we did a 3-dimensional survey of the local universe showing all these galaxies. The dark patch across the middle is the bit of the sky we don't see because it's blocked by our own galaxy. The disk of the Milky Way actually blocks out the galaxies beyond that, and that's why we don't see them. But that was the kind of work, in fact, that kind of work is still going on at Siding Spring Observatory. It certainly was very much the stock in trade of what I was doing when I was astronomer in charge. I also got heavily involved with the dark sky movement because part of my job was maintaining the pristine night skies of the Siding Spring Observatory. And these time-lapse images made by a few colleagues of mine, this one by Angel Lopez Sanchez, who's now at Macquarie University. I wonder if I can show that again, because it's good imagery. The way the sky seems to rotate, but what you can see there is that there is no light pollution. The sky is dark right down to the horizon, and indeed the site is protected by legislation. And so I was very much involved with all that. And then the management of the observatory changed, the governance changed, and my job changed. And so I stopped being the astronomer at large and became what I am now, a person who's engaged with outreach and advocacy in astronomy. And I think it was Jane Urquhart, who's the head of the division of the department that I was working at the time, who suggested that if you made me the astronomer at large, you only had to change 4 letters on the office door. And so I became the astronomer at large, which everybody laughed at, but actually the minister liked it. And that's not Jane, that's Karen Andrews, who's the Minister for Industry, Science and Technology, when she and I had a chat about being astronomer at large back in 2018. Enough of me, enough of all that stuff. I hope everybody who's joining us has now joined us. That was just the entree for what it was worth. Let me now talk a little bit about how you can engage with the sky on many, many different levels, astronomy for everyone. So how do you find your way around the sky? You're outside at night, you can see stars, but you don't know what they are, and you would like to know. There's a time-honored way of doing that, which is a little bit unfashionable these days, but I still like this very much. And that's to buy a thing which has the technical name of a planisphere, but actually it's better described as a star wheel. And it's something that's actually in its lineage, it's very, very ancient. It goes back to the 11th century when these things were being made by Islamic astronomers, made out of brass, beautiful instruments. If you hang on for the last of this series of Cosmic Relief talks, you'll see a picture of one, because I'm going to talk about medieval astronomy in that one. But this is the modern version. It's got a window in it. It's got essentially two parts, a card which has either a window or a hole cut in it. And behind that is a star map, a circular star map. And you can probably see that what you do is around the outside edge, you line the date up with the time, And what you see in the window there is what the night sky looks like at that time and date. And it's a really straightforward way of doing it. The best thing about it is you don't need to charge it up. It's always there, but you do probably need a dim torch to look at it. Across that image, by the way, you can see the band of the Milky Way. It's a sort of negative here, but you can also see the constellations, of which the best known is just to the right of the center there, that centered bearing, or the center pivot, and that's Crux, it's called. It's the posh name for the Southern Cross. Very, very prominent in our skies, not quite for all the year, but for much of the year here in Australia. So that's a great start. They're not much in expense. You can find them online. You can't go into a shop and buy them anymore because of the current emergency, but you will be able to find one, I'm sure. And it's the most basic way of finding your way around the sky. Of course, you can do the same thing on your screen. And if you've got a laptop or a tablet, you can find pretty well exactly the same kind of thing, which has a couple of big advantages over the star wheel. Well, one is that, you know, it's on your screen, so you don't need to take the torch, but not everybody wants to take their computer outside on a dark night. But the big advantage is, first of all, that not only do you see the stars with this kind of software, you also see the planets and the moon. And I'm acknowledging this is from the Heavens Above website, which started off being run by the German Space Agency, is now privately run, but it is a free website and it gives all the details that you might want to know. So it shows the night sky and includes, as I said, the planets and the moon, which you don't have on the star wheel because it's the planets move among the stars. If you're doing it in software, you can see it happening. And the other big advantage is that, unlike the star wheel, which tends to be made for a particular latitude, so you've got to have a different one in the northern hemisphere from the southern hemisphere, you've got to have a different one if you're nearer the equator. Unlike the star wheel, one of these pieces of software, like the Heavens Above website, can be set for anywhere on Earth. And actually, Heavens Above, and notice the hyphen in the URL there, heavens-above.com, that gives you satellite predictions as well. There's a whole wealth of information on it, as well as just finding your way around the constellations, including where to look for to find the International Space Station when it goes by. And that is always worth having a look at because it's so bright and moves serenely across the sky with usually half a dozen, but sometimes more or less astronomers on board. And also the Starlink constellations, which are a relatively new phenomenon. This is SpaceX's huge number of satellites which are being planned to bring the internet to the whole world. Not entirely something that's being smiled upon by astronomers, but SpaceX is working with astronomers to mitigate the effect of all these satellites on their observations. Heavens Above has got a lovely interactive display that shows you exactly where the Starlink satellites are. You can sort of scroll the Earth around. You can twist it around and have a look at where the satellites are going. This is the 6th tranche of 60 satellites. They were launched, I think, on the 18th of March, and I did this screenshot on the 29th to show where those red dots are. They're all in a common orbit, but there will be actually, when this part of the Starlink project is finished, there'll be 12,000 of these spacecraft in different orbits around the world. Make of that what you will. Let me move on to what I think is perhaps the neatest way of finding your way around the sky. And die-hard Luddite astronomers sometimes think of this as cheating, but I don't think it's cheating at all. I think it's a great way of seeing what's happening in the sky. And basically, if you can see me, you get one of these. This is downloadable on your smartphone or your tablet. And they're what you might describe as augmented reality applications. This particular one I'm showing you is from Skyview, which is just one of the many of the proprietary brands of this kind of app. They're augmented reality apps, and what you do is basically load it up, and it uses the GPS coordinates in your device, so it knows where your device is on the surface of the Earth, and also the accelerometers inside it. So it works out where exactly it's pointing. I haven't got it switched on, so don't worry. But basically shows you what is in the sky at that position, assuming that you're holding it more or less at arm's length. So it shows you the constellations, it shows you the stars. As you can see from the image on the screen, it will show you the planets. That's slightly highly magnified, but you can tell immediately what it is, the planet Saturn. And gives you lots of information as well, like the Scorpius that we see there. Scorpius is a large constellation located in the southern hemisphere near the center of the Milky Way, and that's pretty right. Not Scorpio, by the way, that's the astrological term. It's Scorpius in astronomy. And of course, you can do that whether or not the sky is clear. If you hold up your phone on a cloudy night, you can say, well, I will be looking at Saturn if the clouds weren't there, which is not really that comforting, but it's some comfort. I think they are the ultimate sky trainer. I think these devices are fantastic. There are many options. You can choose what you would like to find. They really bring home the idea of what's in the sky and give you a feel for the kind of objects that you might want to look a bit further into. What they don't do, and the Star Wheel and the sites like Heavens Above are great for this, what they don't do is show you the whole sky. And that's often useful. So if you're looking for a particular constellation, you can see where it's going to be. Let me move on a little bit and talk about how you can get a bit further involved in that. Once you've got hooked on pointing your smartphone at the sky or whatever, what do you do next? You can't do any of these at the moment, but after COVID-19, I always recommend finding a local astronomy event. Now, sometimes these are easier to find in the cities, but they do occur in regional Australia as well. Sometimes they're only yearly in some small towns in regional Australia. Coonabarabran, which is the nearest town to where Siding Spring Observatory is, they have an annual astronomy event, which is basically something called Starfest. I can never remember whether it's yes, never mind, Starfest or Skyfest. Starfest, and you know, that kind of thing gets you engaged with people who are interested in astronomy. And at some of these events, you'll get to look through telescopes, or you could go to a planetarium or an observatory. Like Sydney Observatory has viewing nights very, very frequently, and others throughout Australia do as well. Perth, Melbourne, these are all places where you can find viewing nights. I've mentioned starbecues there as well. Starbecue is fairly self-explanatory. It's stargazing with food. It's great stuff. And then something I would recommend anybody who's got an interest in astronomy to do is join an astronomical society. As I've said there, they are absolutely the bedrock of astronomy education. They have they lay the foundations for anybody with an interest in astronomy. So I've got a very soft spot in my heart for astronomy clubs, partly because it was an astronomy club that got me going back in the 1850s. It's really an important part to find people who know and love the sky and can guide you in the way you might want to go. As I've said, it's an accessible and widely available route by which anyone can become involved. Then you might want to invest in some telescopes of your own. Often astronomical societies, astronomy clubs have they have telescopes that they can loan to newcomers, and that's brilliant to be able to do that. That wasn't something I ever managed to participate in. It wasn't thought of when I was learning all this stuff, but it's a great idea. Something else that you can do if you want to get involved is to join one of the many citizen science projects that there are in astronomy. That's certainly a valuable thing to do. And when you do that, you're actually contributing to knowledge as well as hopefully having fun. I'll talk a little bit about that in a minute. And actually another way some people get involved is with specialist travel by going on astronomy tours. So what kind of equipment would you want to buy if you were starting off in astronomy? And I have to say the first thing I always recommend is binoculars, because binoculars are useful in many different ways, not just at night. They're easy to manage. They are good for, especially if you're out in the country in dark sky conditions where the moon's not up, you can see beautiful views of the Milky Way, for example, under those conditions. Or you always get a really nice view of the moon as well binoculars when it's in the sky. Mine is holding a pretty old pair of binoculars of mine there, but they're fitted with solar filters. These are specially designed filters to blot out, or not blot out, but highly reduce the light of the sun. What you must never do with binoculars or telescopes or any optical equipment like that, you should never point it at the sun and then look through it, because that will almost certainly damage your eye permanently. So you have to take very great care when you're using filters like this. There are other ways of pointing telescopes at the sun safely, and we might do a how-to series somewhere down the track of COVID-19 that shows you how to do that kind of thing. Marnie, of course, as you can see probably from her t-shirt, this was during the 2017 eclipse, and we're all watching the sun disappearing behind the moon, or rather the moon covering up the disk of the sun, before it was a total eclipse. That was actually in the Grand Teton Mountains near Jackson Hole in Wyoming. So binoculars are a great start, but then many people feel they want to see a bit more. One thing that binoculars are not very good at doing is showing you the planets. You will be able to see usually the disk of Jupiter, the fact that Jupiter is not a star but a planet, because the binoculars will magnify the disk of the planet enough to see that it's not quite a point. And they might also show you the 4 bright moons of Jupiter, which is great. But then you might want something with a bit more magnification. Binoculars typically are 8 to 10 times magnification. A small telescope like this is the Celestron First Scope, a great marketing venture to bring astronomy, you know, to beginners for really not very much of an outlay. I'm not sure whether they're still $100, but I do know of another similar instrument called a Maxi, which has just been released. That's slightly higher quality, a bit more in price, $200, still within reach of people. And you can get magnifications of well over 20, 30 times with little telescopes like this, which will actually easily show you the moons of Jupiter. And with a bit of luck, you'll be able to see that the planet Saturn is not a point of light, that it has these elongations which with a bigger telescope are revealed as the rings. And really, to be honest, it's all about the money that you've got available, how much you want to spend. Value is good these days. Ever since basically the Chinese optical industry revolutionized optics for amateur astronomers. When I was a young astronomer, if you wanted a telescope, you basically had to make it yourself, because anything that you could buy was very, very expensive. These are very reasonable. So that is a telescope with a mirror 6 inches in diameter. The word Dob is short for Dobsonian, relates to a man called John Dobson, who invented this curious sort of mounting. This is rather an elegant version with the curved side panels, but it lets you just swing the telescope between the two bearings there and move it around very easily. It's a great way of finding your way around the sky. You can see it's got a smaller auxiliary telescope, we call that the finder, and the eyepiece, like the little first scope there, comes out of the side at the top. That's because it's what's called a Newtonian reflector. It was designed by Isaac Newton in the 1660s, and we still use that design. A big mirror at the bottom and a small tilted mirror at the side to bring the light out so you can look at it. And then, as I said, the sky's the limit really in what you spend. This is a different design of telescope. This one, as you can see, operates on Wi-Fi. Many of these more expensive instruments are basically connected they have what's called a go-to system on them, and that might be either through your smartphone or through a little console. You type in what you want to see, and sure enough the telescope will go to it automatically. Once again, some people think that's cheating. I tend to prefer the old way, just because, well, I've been looking at the sky for quite a long time. But I think, again, it's a great way to find your way among the stars. You very quickly pick up what it is you're looking at and whereabouts it is in the constellation if you dial up these things. And let me just move on to more expensive ones. This is a larger telescope with a 9¼ inch mirror. Because many of these telescopes are made by American companies basically using Chinese expertise to actually fabricate them, they're usually described in inches rather than in millimeters, but you get the drift. So that's one with many more bells and whistles. It's on what's called an equatorial mount, which means that is a mounting that tracks the sky sort of automatically, although many of the others do now as well with the go-to systems. You can see that you've suddenly gone up a lot in price though. This is the kind of telescope that you might want to use if you're pursuing some interest in astronomical photography, which we'll talk about in a few minutes. That is where the equatorial telescope mounting comes into its own. And if you really get keen, then you might want to buy a special imaging camera for designed for astronomy, rather than using your own digital single lens reflex camera, which I've mentioned there. But these specially designed digital cameras are actually, you know, as you can see there, range in price from 600 to around about 15,000, because they're basically very similar to the kinds of cameras that professional astronomers use. You might wonder about if you know, you go away from here and you say, yes, I must get a telescope, which I hope you will, where you can buy one. And of course, all the shops are shut at the moment, at least the telescope shops are. But I know that many of them are still operating online. Bintel is one, I've mentioned their name there. They're one of the retailers, I think, in both Sydney and Melbourne. There are others throughout the country, Sirius Optics in Brisbane. These companies are all highly engaged with the astronomical community. They're usually run by people who've come up through the ranks of amateur astronomy, and really all they want to do is not make a fast buck by selling a telescope, but get you involved and give you the best facilities that you might want to take your interest further. What about the resources where you want to find out what's going on in the world of astronomy? News resources, just a few of these to give you some insights. These are ones I use all the time. The BBC, of course, the ABC. The Conversation is a great medium for finding astronomy and general science stories. And these are all really authoritative sites. Washington Post, The Guardian. I'm going to show you a page from The Guardian near the end of my talk. But yes, I've been perhaps a bit unkind there, saying stop before you get to the Daily Mail. The Daily Mail sometimes it publishes stories that really are not terribly scientific, but I guess, you know, it's still worth a look to see what they're doing. Then the online sources, as well as the online standard media. NASA, of course, absolutely full of information about astronomy, about space, about what they're doing. It's fabulous stuff on the NASA websites. IAU is the International Astronomical Union. It's the sort of governing body of astronomy. And they're doing some great things because they're the body that is charged with naming celestial objects. And they've now opened that up to the public. You can actually help to name things like icy asteroids in the outer solar system. ESA, the European Space Agency, ESO, the European Southern Observatory, which Australia is now a strategic partner of, SKA, the Square Kilometre Array. I'll say a little bit more about that in a few minutes. It will be the biggest telescope in the world when it's finished. ICRA is the I think it's the International Centre for Radio Astronomy Research over in Western Australia, and of course the universities. If you look for the .edu on the website, or .edu, I will say edu, it's really education. That's telling you that you're at a reputable source. And the science journals, if you really want to get into it, Science, the great American frontline journal Nature, these are very technical. You would probably need to have, you know, a pretty good grounding in the science that you're interested in to enjoy these, but they do have great stories, and often they have stories that are presented in a popular manner. New Scientist, of course, Cosmos, the Australian Journal of Astronomy, and a few specialist sites. Space Weather is one that we use a lot because it's all about the state of the space environment in which the Earth is located. What's the sun throwing at us? That's all in these specialist sites. Books, well, too many to mention, but I will, because I can't resist a plug for a recent book that came out. Oh, he's plugging his own book. That's dreadful. Never mind. Cosmic Chronicles, which is really, as it says, a user's guide to what's going on today in the universe. It's all about the latest research, but it also gives you some insights into things that you might not think about too much, like the beauties of twilight, what happens when the sun goes down. About, once again, citizen science, I talk about things like that. Where did the moon come from? There's another chapter on that. That's what that book is called if you buy it in Australasia, but elsewhere in the English-speaking world, it's called Exploding Stars and Invisible Planets, because it has to have a little bit more punch. Cosmic Chronicles, I think, was thought to be just a little bit too gentle by the University of Columbia Press, who published the English language edition outside Australia. If you find, you can actually buy it online. Probably the website through which you join this webinar will tell you how to do that. A bit of citizen science. Look at this. This is very much the way of engaging people in doing great research. Galaxy Zoo is a very well established one of many, I think about 200 citizen science projects which go under the heading of the Zooniverse. It comes out of the UK, I think. I think it's Chris Lintott, Oxford, who is one of the brains behind the Galaxy Zoo. But this is taking data from big telescopes, and this picture of a galaxy you can see there comes from the Sloan Digital Sky Survey, which is a survey being done in the United States, because the human eye and brain are actually better at categorizing things like galaxies than machines are. And so that's why there is a place for citizen science in looking at galaxies. You can easily find out more about these from the websites that are given on the page. Here's the SETI at Home website. This is slightly different. This is the search for extraterrestrial intelligence at home. It is taking data from radio telescopes and using your computer when it's not doing anything else to churn through those data. So it's a citizen science project with a difference, because it's your computer that is the citizen. But still, imagine the excitement if you were the first person to pick up a signal from an extraterrestrial intelligence. Sadly, this program's been going for about 50 years, in fact, probably longer now, more like 60 years. And there's been one, as many of you will know, the famous WOW signal, which came in back in the 70s, I think. That's another view of a different SETI at Home interface. Here's another one as well. This is the Globe at Night. This is a dark sky project for people to essentially record how many stars they can see from their location. I'm sorry I've got the 2019 banner for this up. I couldn't find the 2021, but I thought this was rather nice, that it shows the Globe at Night as a project which I think people can get involved with and learn about light pollution. And of course, that feeds back into, eventually it will feed back into local councils and people like that, who are the ones who are designing street lighting and urban lighting with a view to preserving the night sky, because we now know that damaging the night sky is not just bad for astronomers, it's bad for nocturnal species and ourselves, in fact, because it upsets our circadian rhythms, as well as being a waste of light and a waste of energy. And I mentioned specialist travel as well, which is something rather close to my heart. Manny runs a specialist travel company. One of our most popular types of tours is up to far northern Scandinavia to see views of the Aurora Borealis, which occasionally are as dramatic as this footage by Ole Salmonsen, one of Norway's most prolific aurora photographers. I'm taking up too much time here, so I'm going to move on, because we are really in the bit of the talk that I think is perhaps the most spectacular, and that is these images by amateur sky watchers who've gone through the process that I've outlined. They've bought the telescopes, they've bought the cameras, and they've got the energy and the enthusiasm and the love of the sky to make these marvelous images. And these pictures come from something called the David Merlin Awards. David Merlin, the person who first put colour into night sky images, true colour, which he did largely with the Anglo-Australian telescope here in Australia. He's a colleague and good friend of mine. He is very happy for me to show you some of the images that come from entries now being put forward by amateur astronomers for the awards that he put in place more than a decade ago. They're run by the Central West Astronomy Society in Parks, and they have the annual David Merlin Awards. These are just some of the images from the 2018 David Merlin Awards, and they are absolutely stunning. These are pictures that would have blown away a professional astronomer 20 years ago, and they're now being done by people who've got nothing more than some perhaps expensive equipment, but a love of the sky. This is a globular cluster, a giant star cluster in the constellation of Pavo. It's one of Steve Crouch's photographs. If you look in the bottom right-hand corner, you'll see the authors of all these images. Globular clusters, tens of thousands or hundreds of thousands of stars. We think they are the remnants of old dwarf galaxies that have been gobbled up by our own galaxy, to make it a big one looking like this from the outside, except this isn't ours. This is one with the lovely name of NGC 2997, Brett Turner's image, which again was commended in the awards. Here's another galaxy image. This is a slightly more edge-on spiral galaxy. It's often called a silver dollar galaxy. NGC 253, we really know how to give names to things. I think silver dollar has a slightly better ring to it by two again. This one is a stunning image of basically a dust cloud in space. It's what we call a dark nebula, and it's a place where star formation is taking place. And the colors that Peter has put in this are very close to the colors you will be able to see if your eyes were millions of times more sensitive. Here's perhaps one of the most famous galaxies, the nearest galaxy to ours, and you might notice that we've changed category here. They were deep sky images. These are wide field images. In other words, a wide angle of sky, the Andromeda galaxy, 2 million light years away and serenely hanging in the northern sky. We can see it from here in Australia, but this image, I think, was taken from the north. Beautiful image there. In the wide field, of course, you can actually include the landscape as well. And there's a movement called TWAN, which is the world at night, which is great for taking photographs like this of the night sky and the landscape. This is a brilliant picture by Greg Priestley, which shows on the upper right and just hidden by that little blob of cloud there, the saucepan, which is part of Orion, the Hunter. In the middle of the upper part of the picture, there are the Hyades star cluster, and to its left, the Pleiades star cluster, much more compact. Still just about visible in our skies, evening skies at the moment. I think they're probably setting actually before it gets dark, but they'll soon be in the morning sky. But look at the pink blob below. They are what are called sprites. And they are the upward discharge that come from some thunderstorms when you see them 100 kilometers away or so. Until 10 years ago, people didn't believe these things existed because they were noted by a few airline pilots, but it's only with modern equipment that you can actually photograph them. A lovely portrait of the Barrenjoey lighthouse, not very far from where I live, Milky Way arching above it by Tom Elliott there, lovely. Star Trails, the colours of the stars. David Merlin's first big selling book was The Colours of the Stars. He became world famous because of his work in colour astrophotography. And it's great that, this award scheme allows amateurs to aspire to the same kind of thing. Star Trails, you let the sky rotate and the stars trail their images. Starfall on a Dry Landscape by Ian Imberati. What a lovely shot. Here's another wide-angle view. That little cluster of stars is something I was looking at through a small telescope a couple of nights ago. It's called the Jewel Box. And you can see why. It's got multicolored stars in it. So Peter Ward has called this image Here There Be Treasure. The funny colors up on the upper left there come from a very bright star. It's actually one of the stars of the Southern Cross, Beta Crucis or Mimosa, which is just out of the field of view there. I like this one too. The Drover's West, the Milky Way, with someone who probably wasn't standing still for a while. It might be a statue, but what a great image. And another star trail picture by Ben Swanson, Night Glow, very, very pretty stuff. And then the category of the solar system, I'll whisk through these. We don't have much time left, but let me show you this lovely image again by Peter Ward. You might say, well, that's pretty ordinary, it's just the full moon. But when you take a picture of the full moon, you might struggle to get this in it because Peter's captured the International Space Station going across the sky between ourselves and the moon in this image called Lunar Transit. Fabulous stuff. And I can't let this talk go by without showing the pearl of the solar system, the planet Saturn. a lovely image by John Cazanas, the rings and belts of Saturn. It won't look like that through your small telescope, I have to say, but it's always a pleasure, even squinting through to see that you can just make out the rings. It's still a delight to look at Saturn. I love this one as well, another nightscape. This is another category. This clearly taken from very near Hobart, I think, of the Aurora Australis, the southern lights, with a rainbow cast by the light of the moon. It's a beautiful shot by Jason Beatty. And another ephemeral phenomenon of the night sky. This is a fireball, a bright meteor, a piece of rock, probably not more than a foot in diameter, burning up to a bright flare in the upper atmosphere. And finally, the winner, which is a crescent moon, which is kind of overexposed, so you can't see it's a crescent, but it probably is, plus the Milky Way, plus Lake Oberon in Tasmania by Luke Sharker. And that actually was the shot that was the overall winner for the 2018 David Merlin Awards. A beautiful shot. Let me move on. We're running out of time, but I hope we'll get everything in before you all start going to bed. Let me take you a little bit deeper. What can you do? What else can you do? The kind of steps that you might want to take. First of all, take your membership of an astronomy club further. Join the committee. Volunteer at one of the public observatories if there's one nearby. Perth Observatory and Sydney Observatory. Probably Melbourne too, run very strongly on their volunteers. And then if you can, as I mentioned earlier, some sky watchers have turned their interests into a job, specialist publishing. There's a classic example of that here in Australia, and it is almost unique in the world. It's a stunning publication. Telescope sales, if you've got a telescope shop and you can work for them. Education services like planetariums. There are blow-up planetariums that go around schools when there's no viruses, and sometimes people do social media work. And the main thing is a career in professional astronomy is not just about being a research astronomer. There are many other different roles, and I can't resist showing you this, which is a young night assistant by the name of Rob Dean at the controls of the Anglo-Australian telescope when it was brand new. This is the one I showed you earlier. Brand new in 1974. The telescope's still going strong, and so is Rob. The control console has changed less than he is, if I can put it that way. Rob's now retired, but still very engaged with astronomy. And look, what an opportunity we've got here in Australia, because the biggest telescope in the world will have its Australian, or a part of its operation, actually, its low frequency operations. It's a radio telescope in Western Australia. These Christmas trees are prototypes for this thing called the Square Kilometre Array, the SKA. Which has the attention of many, and of course the contribution of many institutions here in Australia, including the department that I work for. It's a global operation, a worldwide project. You can't build big projects without many nations contributing, but the telescopes are distributed between Western Australia for the low frequency radio telescopes and Southern Africa for the mid frequency. And the headquarters, as you might be able to see there, is Jodrell Bank in Manchester in the United Kingdom. So that project, I know at the moment, and they're looking for engineers. So keep your eyes open if you are interested in a career in astronomy. So what does astronomy need? Well, it needs electronics engineers and technicians. It needs optical engineers and technicians. It needs mechatronics engineers and technicians, software engineers, IT specialists, project managers. All of these are roles that take place within the world of astronomy. Technical writers, people, I guess, like me, doing publicity and communications. Specialist administrators are the kind of people who know how facilities like observatories and university departments run. And even astronomers. But it's true that in the world of professional astronomy, you do need to have done the hard yards. You need a fairly strong background, physics, mathematics. The sciences now include biology, because astrobiology is part and parcel of our studies, as well as the physical sciences. Astrochemistry, these are all sciences that are actively being worked on now. And a message that I'd like to stress is it's never too late. Well, it might be at some stage, but don't think that you've missed the boat, because that may not necessarily be true. And I'll confess, and this must not go beyond these four walls, you're all sworn to secrecy. I didn't get my PhD until I was 42. That wasn't a number chosen because it's the answer to life, the universe and everything. It's just when it happened to arrive. So it's never too late. Let me briefly, I'm right at the end of my talk now, just tell you that astrophysics and astronomy is not always just the esoteric study of the universe, because bringing this right up to date, this is a project by Swinburne University of Technology in Melbourne to build a software package called a symptom tracker. And it's not going to cure you of the COVID-19 virus, COVID-19 illness, but it will allow people to track the progress of that illness. And so why am I showing you this? Because the algorithms that it uses were based on astronomical algorithms. They have their roots in astronomy. Astrophysicists have worked on this, and it means astronomy is contributing to something that is very much an issue today. One other thing about astrophysicists is that sometimes they're fantastic at keeping their attention on the universe at large, but sometimes they do things that might raise an eyebrow or two. Oh, but that's the that's the link to follow if you're interested in Beat COVID-19 Now. BeatCovid19now.org. Going to the unusual things that sometimes happen, and once again, it has a connection with Swinburne. I love this headline: 3 days. Astrophysicist gets magnets stuck up nose while inventing coronavirus device. It's exactly what astrophysicists do. Poor old Daniel Reardon down in Swinburne there wound up in hospital because he was trying to invent something that would warn you when you touch your face. But what he did was essentially magnetized his nose and couldn't get the magnets out. But what a headline. I think astronomy and astrophysics often brings interesting people to the forefront, and we do interesting things, and that's just part and parcel of life. I hope this talk has whet your appetite, or should I say whetted your appetite, for learning more about astronomy. There will be more in the series. We've got 3 more in this series, and we might do another one. The next one's about Mars and whether we should be traveling there. So ladies and gentlemen, thank you very much. Thank you for hanging on with this. I hope your IT's been okay, and we hope to see you next time. Thanks very much.
Yay! Thanks, Fred. I hope everyone has enjoyed it. There were a few little tiny glitches with some movies and some sound issues, but a lovely talk, and gave everyone a really good understanding of the beginning, so that when you start talking about some of the more intimate and intricate parts of astronomy, we can do that in the coming weeks. Yeah. So we have a couple of questions. There's lots of lovely comments coming through. Thanks so much, Fred. Thank you so much. Questions for Fred. Yes, if you've got any questions, type them up now. But I do have a question that previously came to me, which was sort of touched on in the talk, from Tony Allen. Fred, how does a spiral galaxy maintain its shape? Are the outer stars travelling faster than the inner stars, contrary to the laws of physics?
Well, that's an absolutely leading question, because that is kind of what was expected. When people looked at the way stars move in galaxies, they do rotate. All the physics you've ever learned will tell you that the stars nearer the center should be rotating, or should be traveling faster around the center more quickly than the ones on the outside. And we find that's not the case. We find that once you get beyond the central region, what's called the rotation speed is pretty well constant. And the only way we can have that is if there's something there that we can't see. And it was actually Vera Rubin, one of America's great astronomers, in 1978, who suggested that perhaps galaxies generally are encased in a cocoon of something we call dark matter. That's not the only evidence for dark matter, but it's the one that made people sit up and take notice. So it doesn't contravene the laws of physics if you include dark matter. Sadly, we don't know what dark matter is yet, but we will. We will, I hope, because we're working on trying to find it very hard. We might do a talk about dark matter actually down the track on the webinar series if there's enough interest. Marnie, I think I'm going to stop sharing my screen, and I'm going to come and join you for the rest of the questions. How's that?
No, stay where you are.
Oh, all right. Okay. All right. I know my place.
Okay. So Lynn has a question. Lynn, did you want to ask Fred the question? Sorry, I'm unmuting you. Lynn.
Yeah. Lynn's showing up as muted on my screen.
Yeah, I can't unmute her.
Okay.
There you are.
I wasn't asking a question, but I'm a Lynn Chavot, so maybe there's another Lynn. No, I would like to ask more about dark matter, but obviously you're not going to talk about that now, I believe. Is that correct?
Well, I can say a little bit more. We will talk about that, I hope, in another webinar. There are many, many astronomical lines of evidence that tell us that there is something there whose nature is curious, because it doesn't interact with normal matter. It doesn't block off light or anything, but it has gravitation. And that's how we see its effect. We see its effect on the rotation of galaxies, on the movement of galaxies in clusters, all of that. And actually something called gravitational lensing also reveals it. So we know it's there. Now, we don't know what it is. The idea that it might be black holes or dead stars or orphan planets, that was all ruled out back in the 1990s. And so we're left with some species of subatomic particle. And that's why the focus has really shifted to the particle physicists, who are working very hard to try and work out what it might be, as well as the astronomers who are constantly or continuing to look at new lines of evidence as to how you can reveal what dark matter is. There are some ideas, neutralinos, sterile neutrinos is another one, I think. Axions are one of the things that have been, these are particles that we don't know whether they exist, but they seem to have some possible theoretical framework. So work will go on, Lynn, and eventually we will work out what dark matter is, and it might even turn out to be useful. You never know. The thing that should perhaps reassure you is that it outweighs the normal matter in the room you're sitting in by 5 to 1, and yet you can't see it or feel it. So very interesting stuff.
Thanks, Fred. I have a question here from Henry Smith, and I'm trying to unmute him. Henry, are you there?
Yep.
Hey, good to talk to you, Henry.
Hey. So me and my mum were thinking of this thing. Maybe since we can't go at the speed of the light, speaking of dark matter could be useful. Maybe we could use dark matter as an infinite energy source to go at the speed of light. And also, I've got one of those miniature telescopes.
Oh, fantastic.
$100 ones, I've got one of those mini ones. I've got the exact same one, except mine has a picture of a moon on it.
Do you enjoy using it, Henry?
Yeah.
Great.
I actually used it to have a look at some trees just...
Good. Trees are good.
Yep, about an hour ago. And once I even saw the moon with it.
Yeah, check out the moon over the next few nights, because it's in our evening sky and it's getting bigger as it goes around the Earth. Look, your question's a good one. Physics tells us that we can't go at the speed of light, because to do it, you'd need infinite energy. You would absolutely need infinite energy to travel at the speed of light, and infinite energy doesn't exist, even in our big universe. It's not impossible that one day we might be able to travel close to the speed of light, and that would certainly be a lot easier to travel around our part of the galaxy than we can at the moment. But once again, physicists are engaged with this all the time. What a lot of physicists are looking for, and dark matter might be giving us hints of that, is something called new physics, that essentially shows you where the weaknesses are in the physics that we understand at the moment, and might open up all kinds of possibilities. So new physics is something always to watch for. It's what astronomers tend to be interested in, as do the particle physicists. Great question, Henry. Thank you very much.
Okay, and I've got a comment here from Cass. Cass, I don't know if you're there. Do you want to shout out about AstroQuest?
Awesome. Thanks, Marnie and Fred. Hey, I work at ICRA, who you did before. And I'd like to say, everyone, please head to astroquest.net.au and sign up to be an AstroQuester. It's our citizen science project, and we're looking for more and more people to sign up and help us understand how galaxies grow and evolve.
That's great. Cass, can you drop me an email about that, and I'll do my best to promote it as well.
Will do, Fred.
Yeah, thank you very much. Great stuff. More
Okay,
citizens we've got, the better.
Sorry about that. So Yogesh wants to know, when would we be able to see the near-Earth asteroid which was discovered recently?
So the one that I'm not sure whether you're thinking of is one that was very, very small. It was only a few meters across, so it needs big telescopes to see it. There might be others that I've missed, but that's the most recent one that I've seen. It was discovered by the, what's the project? I can't remember. It wasn't Pan-STARRS. It's another of the near-Earth asteroid projects, and was, you know, the kind of thing that you really need a big telescope to see. When there's a near-Earth asteroid bright enough for people to be able to find in their own skies, you'll definitely hear about it because it'll be big news. Most of these things pass us by. They're only a few meters across, and we don't see them with small telescopes.
I've got another question here. Hi Fred, Val from Western Australia. Are there any websites you recommend for children to get interested in astronomy?
Yes, there are. Actually, most of the university website. So Cass was just talking about ICRA a minute ago, the International Centre for Radio Astronomy Research.
Hi.
And they do a lot. That sounded like Henry again. They do a lot.
I had to unmute myself.
Yeah.
I just muted him.
Yeah. They do a lot that's you know, that's engaged with younger people, as do some of the schools around, particularly the ones that are clustered around institutions like ICRA. So I've got a few things in my mind because I know that some of the big projects that are going in Australia, like something called OSGRAV, and another one called Astro 3D. These are major projects that involve large collaborations of universities, and they have specialist education officers, and they are running websites which are designed specifically for kids. So OSGRAV is one to look for. ICRA is another. ICRA might fall into the Astro 3D, which is one of the others of these large projects. And there are more to come too. It's really a question of going online and maybe even just, you know, putting into your search engine kids astronomy projects. I do have access to those resources, but it's just pulling them out of the back of my brain at the moment.
You can drop us an email if you want. If you drop us an email with those questions, we can get back to you as well with those sorts of things as well. So yeah. I think we've got maybe 2 more questions. Fred, are you doing a talk on exoplanets later in the series?
I think we might put that into the next series because dark matter and exoplanets are 2 of the hot topics in astronomy at the moment. Let me just tell you what the series looks like at the moment. We've got Mars next time. This is in a fortnight. The time after that, I'll be talking about fast radio bursts, which is something Australia is very heavily engaged in. This is a mystery. These are these bursts of radio radiation that come from all over the sky, and we don't know what they are. And then I'm going to basically delve into the past because I'm also very interested in the history of astronomy. So we'll have a gentler talk. This is going to be in the 4th one from now, so in 8 weeks' time. That will be on medieval astronomy. But then what we will probably do, if there's enough people who are interested, we'll go on for another series. I think we'll still be in something like lockdown then. We'll do, and your voice has been heard. We'll start off with exoplanets and we'll do dark matter, or maybe even the other way around. So yes, we will. Long answer to a short question.
Okay. So I think we might finish up. I've got a few personal questions here, which I'll get back to with just some websites. But Bill
Could I-
asks, how do we get councils to switch off street lights? And of course,
that's a question for Marnie, is that?
that's a question for me, being the dark sky person that I am. Look, it's a question about making sure you speak to your councils, and that if you do have an issue, that you let them know about the streetlights that are affecting you. Councils are actually getting much better with understanding that light is a pollutant, and that it's a wasted energy, basically. It's also a resource that should be used wisely, not used abundantly and overused. So councils are actually starting to listen, but what we really need is for people like you who are trying to look at the stars to actually raise your hands and say, you know, let's make it go. Let's start turning off some street lights. So there's no short answer to that, but the more people who start looking at the night sky and the more people who want street lights turned off, the better in my world. Fred, were you going to say something?
All I was going to say was, just before we sign off, we should mention that anybody who's truly addicted to astronomy, I'll be doing my regular weekly segment on ABC Sydney, which you can get online as well as on the radio. In about 45 minutes, I'll be talking to Sarah McDonald, and there's a few interesting things coming up, like the fact that Uranus emitted some, well, it was a cloud of gas that was back in the 1980s, but it's only just been discovered. And there is a new spacecraft looking for, not looking for exoplanets, but looking at characterizing them, what we can learn about them, and a few other things besides. So we'll be talking about that, as I said, in about 45, 50 minutes on ABC Sydney. That was a shameful plug, but never mind.
So everyone who's left, I see we've still got most of you online, which is fantastic. We, I think everyone ran off to get their dinner just as we started to finish off the questions. But we look forward to seeing you in 2 weeks' time for Mars, not our planet B. And if you haven't already registered for it, please go to Dark Sky Traveller events page and you can register there. But thank you. Thanks again to Fred, and we'll see you soon. Thank you.
Thanks, Marnie. Thanks, everybody. Great to
Bye-bye.
see you. Bye.